I'm now very happy and proud to present to you our next speaker. It's Mr. Danrong Song. He's the chief designer of Linglong Nuclear Power Institute China, the SMR reactor that you're building there. So please, Mr. Danrong Song, take it away.
Good afternoon for all the audience. Thanks a lot to have this opportunity to introduce our SMR. My name is Danrong Song from Nuclear Power Institute of China. I'm the chief designer for the SMR Linglong 1 SMR in China. And now the Linglong 1 SMR is already under construction in the south of China. So my presentation is multiple application of Linglong 1 SMR in the field of district heating and desalination. So next, please. The presentation of my today is about the SMR ACP100. There are following contents I will introduce about the background, introduction of ACP100, design parameter of ACP100, its technical aspects, safety and licensing strategy, testing and verification, and the demonstration project of ACP100, and the multiple application of Linglong 1. Next, please. We now know SMR is one kind of new generation reactor designed to generate electric power up to 300. Next, please. SMR is adopting modular design and construction concepts. Passive safety technology can reach large power by several modular combination, and it can be used in different places and different conditions. Next, please. We know large nuclear power plant also can generate a large amount of electricity. Why should we develop SMR? For SMR, it benefits from the capacity and transportation. It can be used passive technology, and large nuclear power plant construction have a huge overnight investment, and it not flexibility and for different user, different application. SMR is more flexibility and can be used in inland or remote area. Next, please. We know in 10 to 20 years, according to the national organization, so 70% of the energy consumption in developed countries is non-electrical application, such as heating and transportation. Next, please. Not like a large nuclear power plant, SMR can achieve its economic by simplifying by modular design and by increasing number of modular. With lower power and lower residual heating, SMR is suitable for passive safety facilities. Next, please. SMR is suitable for small electricity grid, district heating, process heating supply, seawater desalination. According to different conditions, different countries have different goals for SMR. Next, please. From the IAEA booklet, there are 72 reactors in 18 member countries in 2020. They developed the 1/3 of the SMR are PWR type, and most of them are integrated reactor. Next, please. In CNNC, China National Nuclear Corporation, we called our SMR ACP100. It's an innovative PWR based on existing PWR technology, adopting passive safety system and integrated reactor design technology. We start to R&D on ACP100 from 2010. The modular design technique is used to control the product quality and shorten the site construction period. Next, please. This is a roadmap of ACP100. We started in 2010, and PISA report approved by our National Nuclear Safety Authority in 2020. Next, please. The design parameter of ACP100 is following. Thermal power is 385, electric power is 125, and the design life 60 years, refueling period 2 years, and the inlet and outlet temperature is about 300. There are we use the 70+70 shortened assembly. The active section height is 2,150, and there are 57 shortened fuel assembly inside the reactor. Next, please. And there are 25 control rod, and steam generator type is 1-through steam generator, and there are 4 canned pumps connected the reactor vessel. Next, please. And the CDF and the LERF is lower than 10-7 and 10-8 per reactor year. Next, please. One reactor with one turbine. With one turbine. Next, please. The reactor coolant system has been integrated reactor module. The reactor module consists of reactor vessel, 1-through steam generator inside the reactor vessel, and 4 canned pumps connected with the reactor vessel. Next, please. And the ACP100 adopts fully passive safety system, including passive core cooling system, passive residue heat remove system, passive containment heat remove system, passive inhibitory system, and automatic depression system, passive hydrogen control system. Next, please. Next, please. And the code and standard applied by ACP100 is level 1 laws issued by the Congress. Level 2 is the code and the regulation issued by the State Council. Level 3 is departmental rules issued by government organization. And level 4 is guide issued by government organizations. And the technical level 5 is technical documents issued by government organization. This is next, please. This is the code and the standards applied by ACP 100. Next, please. Safety design conception of ACP 100 is no active emergency core cooling system, no active containment spray and recirculation system, no need for operator invitation after accident for 72 hours, no safety-related emergency AC power. NSSS integrate design minimize both the possibility and the impact of design-based accidents. Mitigate DBA without non-safety system. Emergency plan zones is limited inside the site boundary. Next, please. Severe accident prevention and mitigation measures, including the automatic pressure release system, passive hydrogen recombiner, passive containment heat remove, reactor cavity flooding by gravity water injection. Next, please. Next, please. And we also do the third-party verification. IAEA gave the review comments on ACP 100 generic reactor safety review GRSR report on April 2016. This is the first SMR completion of GRSR in the world. Next, please. According to the safety documentation, the ACP 100 plant is an innovation design that belongs to the SMR class of NPPS and deploys passive safety features. It can be expected from new design that they are capable of dealing with extreme environment conditions and multiple failures to assure the early or large radioactive release are practically eliminated. Next, please. We also done a lot of testing and verification during our R&D for ACP 100, including the control rod drawing cold and hot tests, control rod drawing line anti-earthquake test, internal vibration test, fuel assembly critical heat flux test, passive emergency core cooling system integration test, CMT and passive residue heat remove system test, passive containment heat remove testing. Next, please. Now, I will introduce the demonstration project of ACP 100. The demonstration project located in Changjung nuclear power site, Hainan province, in the South Island of China. The first concrete date is in last year, in July last year. Construction period of the first of this kind in 55 months. Target commercial operation in 2026. Next, please. There are 600 nuclear power plants already operating on this site, and 1,000 Hualong nuclear power plants under construction, and 1 ACP 100 under construction from last year, start in last year. Next, please. Major equipment such as reactor pressure vessel, steam generator, and turbine already in manufacturing stage. Next, please. This is the site preparation on 2019. Next, please. This is the site preparation in December 2019. Next, please. This is the site preparation before FCD last year. Next, please. This is the site preparation in last year. We can see the reactor containment is already on site. Next, please. This is the FCD on July 13, 2021, and we construction well in last half years. Next, please. So let's go to the multiple application of ACP 100. Although we started the demonstration project of ACP 100, we will use ACP 100 in near future for multiple application. We know the nuclear energy have higher density, lower carbon emission, stable operation, no fluctuation. 1 kilogram of uranium equal to 2,070 tons of coal, and 1,000 nuclear power plant can decarbonize 6.6 power of 7 tons of coal. Next, please. According to the estimate calculation in China, 80% of end user of energy, including electricity, heating, and transportation. In year 2019, energy consumption in China, electricity about 23.9%, heating 45%, including the industry 24%, civil 21%, and the transportation 11%. We can see a lot of end user of energy is heating, not only electricity. Next, please. There are increasing electricity demand in China from 70.5 square of 13 kilowatt hour in 2020 to 1.17 power of 14 in year 2050. Portion of fossil plant will decrease from 63% in 2020 to 20% in 2060 in order to achieve the decarbon goals of our country. Several choices for replacement of fossil plants is wind and solar, hydropower, and nuclear energy. And we know the nuclear energy can access grid stable and as a baseload energy. The heating, the heating, two-thirds of the heating, two-thirds of the heating are used for industrial area. 40% of total CO2 emission of the world. Nuclear energy can play a key role in heating area. Next, please. We have do a feasibility study on Scpr 100 in the field of electrical generation in Hainan Changjung project. The first kind of our demonstration project is under construction. The electric power is 126.5 megawatt electrical. Refueling period 24 months. Electric generation is 10 power of 9 kilowatt hour per year. It can satisfy for 500,000 families. Next, please. In the field of district heating and electrical generation, we have done the feasibility study in Gansu province. The thermal generation is 6.55 million gigajoule per year, and the electric power is 80 megawatt electrical. So in this project, we can output district heating and electricity and both. Next, please. In the field of seawater desalination and electrogeneration, we can done the combined with a low temperature multi-effect seawater desalination facility, we can generate 48,000 cubic meter per day, the fresh water, and the electrical generation is 75 mega electrical. Next, please. We can also, due to the small reactor, we can use the Scpr 100 on the floating plant in Shandong Yantai project. We done the feasibility study. The two Scpr 100 reactor can be mounted on the floating platform and can generate 250 megawatt electrical power. Next, please. So that's my presentation. Thanks.
Thank you so much. Well, I have a few questions. First of all, fascinating, talk that you gave. Do you see, if you talk about this Scpr 1000, do you think the main application will be as a combined heat and power production unit? Is that the main benefit of this?
For the first kind of SMR already under construction in Hainan province, we used it as a electrical generation, and combined with 2,000 and 3,000 seawater desalination. The water is used only for the plant itself, not for the civil use, not output for the people.
Okay, so but do you see, like, is that going to be a main feature of this? Do you think the design is particularly well suited for producing both heat and electricity, or is that you can choose that as you wish, but depending on the way you construct it?
For the first kind of SMR in China, we want to demonstration for its safety. It can be built near the user. We should we should prove its safety and prove its operation. So in this site, we not use a lot of application. But in near future, we will combine with the heating and the desalination.
Okay. And do you think this reactor, is that intended also for export?
It depending on the country demand, on the other country demand. Yeah, a lot of island country like Indonesia and countries like Middle East, they want to SMR for desalination.
And can you give us an idea of the cost per installed megawatt electricity of this reactor?
For this SMR, for this first kind of SMR, it's the price is higher than large nuclear plant. The electrical price is about 1.6 to 0.66 or 0.7 yuan renminbi. Large nuclear power plant is only 0.4, so maybe a double for this SMR.
But that's for this first of a kind. You know,
yeah. Yes.
And to get meaningful cost reductions, how many plants do you envision you'd have to build to get that cost down to say something that's close to large-scale plants?
We have done the calculation. If we build 4 or 6, the price will be 70 to 80% of the first kind.
Okay. And I noticed that the construction here, the building time seemed quite short. Was it about 2 years? Is that correct?
No, the first kind of this plant this SMR is about more than 4 years, because the equipment is new equipment, the factory, and they need to build more time. But on site, the concrete, the time for concrete for buildings, it's much shorter.
And when you say much shorter, how much is that?
Maybe 2 years can be all the buildings, but the equipment, we start the equipment maybe in the following plant, we can start the equipment manufacture more earlier and comply with the site construction time. So by this way, we can shorten the construction period, total construction period, less than 3 or 4 years.
And do you envision that you will build a large sort of portion of the plant in one location, in sort of a factory of the reactor, and then transport the reactor in pieces and just sort of assemble it on site? Is that how you envision the production?
In this demonstration project, we already combined the reactor vessel and the steam generator in one factory and transport it combined on site. Nothing to do on site for steam generator and reactor vessel. No need to welding them.
So yeah, that's interesting. It's often held up as a benefit of these small modular reactors to do what you describe. So I think unfortunately we're out of time. As always, I wish I'd have more time. This is super interesting. There's so much going on. So thank you so much for taking the time with us today, Mr. Song Danrong. And then
Thanks.
I hope that we'll meet again in the future. Good luck with your plans.